In this tutorial, we're going to talk about inequalities in triangles. And the first thing that we want to look at is the first theorem in this section, which is theorem 5-10. And it says, if two sides of a triangle are not congruent, then the larger angle lies opposite the longer side. So let's take a look at the picture. So here in this picture, let's try to focus on two particular sides. Let's look at XZ, so this right here in red, and let's compare it to XY. So if I were to compare these two sides, I know for a fact, just by looking at this picture, that segment XZ is greater than segment XY. And if this is true, then I know that the measure of angle Y is going to be greater than the measure of angle Z. Because in my picture, this angle right here is directly opposite of the longer side. So this has the bigger angle. And that's all that this theorem says. It's a very basic theorem. So let's take a look at this example. We're going to list the angles in order from least to greatest just by knowing the length of the sides. So the side with the smallest length, this guy with 18, segment XY, is the smallest side. Therefore, the angle opposite of it, which is right here, angle Z, is going to be the smallest angle. So I'm going to say angle Z is going to be first. I'm going to take a look at the second to largest side, which is YZ, and the side opposite of that is angle X, so that would be the next largest angle. And then the longest side is a length of 30, and the angle opposite of that is angle Y. So that's how we're going to look at this theorem and how we can use it. And in your textbooks, there's another theorem called theorem 5-11, and it says pretty much the same exact thing here, except with angles instead of sides. So please look it up. It's on page 201, and add it on your theorems and postulates charts if you'd like to. And here we have the big kahuna theorem of this section, called the Triangle Inequality Theorem. And what this says is that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So in this picture, let's take a couple sides. Let's try XY first. And we are going to add that to segment YZ. And what this theorem says is that the sum of these two sides of this triangle will be greater than the length of the third side, which in this case is XZ. Well, okay, let's take two different other sides. Let's try XY again, and this time add that to XZ. And the same exact rule applies. The sum of those two lengths is going to be greater than segment YZ. Well, what about the other two pairs? How about YZ and XZ? And the same exact rule applies. The sum of those two sides is going to be greater than XY. That's what this theorem says, and that's super important because the only way that a triangle can be formed is if this is true for every pair of sides that you have. So let's take a look at an example. This question is going to say, can a triangle have sides with the given lengths? So in our picture, I wrote up the lengths for this particular example, This doesn't necessarily mean that it forms this triangle, but we're going to see if our theorem helps us determine that. So let's take two sides of our choice. Let's try 3 and 7 first. So I'm going to do 3, and I'm going to add that to 7, and that sum should be greater than the third side. So is this a true statement or is it not? Well, 3 plus 7 is 10. 10 is greater than 8, so far so good. Let's try adding the 3 and the 8 next. So 3 plus 8, and that should be greater than the other side, which is 7. So 3 plus 8 is 11. 11 is greater than 7, so this works as well. Let's try the third pair, which is going to be 7 plus 8, and that sum should be greater than 3. And 7 plus 8 is 15. That's definitely greater than 3. So these actually would make a triangle, and all of the sides would connect. And that's pretty cool. And that concludes this tutorial.